Alright, today's lesson is about functions. Functions are sets of ordered pairs which tell me that exactly one y exists for every one x value. This is just a continuation on what we were working on the other day. This will tie directly into graphing points in just a bit. So, my input is going to be my x value. That's just going to be the number that gets plugged in to the general function that I'm about to give. The output is going to be my y value, or if you want to go in layman's terms, it's going to be the answer. Alright, a typical function is going to look something like this. Again, we're just going to make one up, and I'm going to give I like doing color coding. It helps me get a bit of a picture here. Y is equal to let's see here, how about 4 is a good number. 4x, you can add a constant in there. How about 1? We're not going to make it too hard right now. A couple things are going to happen. Got my function. Let's see here. Got my input value, got my y value, got my constant, got my slope. We'll get into that later. Let's see what happens. I'm going to make a nice little x and y chart. This is just a more organized way of giving me data. What I could do, if I didn't feel like learning this on my own, is plug in this function formula into my calculator, and it'll give me hundreds and hundreds and hundreds of x and y values, because that's what they're intended to do. If I want to build that skill for myself, or say when Mr. McDougall doesn't let you use a calculator on a later basis, I'm just going to get used to this plugging in method. So I'm going to pick some random points, -2, 1, 0, and 1. Why not? Because I can. You'll see me make some more organization in just a tad bit. What I'm going to do is plug in this is called an extended XY graph. This just shows what I'm doing in the middle. It's a little bit of organization. All I'm going to do here is plug in my new x value to the original function. Set it up because I don't like being tedious. So let's plug in this x value. -2, 1, 0, 1. It's kind of like, honestly, it's kind of like doing 4 different problems, if you want to think of it that way. 4 times -2 is -8. Maybe I can do a little math off to the side here. -8. Keep going. Plus 1 is going to give me -7. 4 times 1. Sorry, that meant to be negative. 4 times -1 is -4. Plus 1 is going to give me -3. 4 times 0 is 0. Plus 1 is just going to give me 1. 4 times 1 is 4. Plus 1 is going to give me 5. So again, all I'm doing is taking these x values and plugging them in here. This in the middle here, we're calling the rule column, or what I also like to call the what's going down, or the what happened column, is really just, it's organization. If you don't like writing stuff off to the side, then, you know, if you do like writing off to the side, you can put it over here. It doesn't really matter. The most important things that you have are the X and the Y column. Alright. Now, for those of you who are thinking, okay, not too bad. And those of you thinking, Mr. McDougall, what the heck are you doing? We've been doing these input and output problems ever since we first learned how to add, without even knowing it, without even using these XY charts. What I'm going to do, leave this here just as a comparison. Make a little box, because I don't really have that much room here. One of the easiest problems that we could think of in elementary school. 1 plus 1 is equal to 2. Let's take one of these values, make it a variable. 1 plus x equals y. Does that look like a function formula? I think so. When x is 1, y is 2. Let's keep going down. One plus 2 is equal to 3. 1 plus 3 is equal to 4. 1 plus 5. Yeah. 1 plus 4 is equal to 5. The beauty in these linear graphs is the constant patterns that you'll see. And on that note right there, we're going to work on something called the vertical line test. What the vertical line test is that it shows me if a graph or a set of data is a function or not. If it has 1x for every 1y. So I'll write that down for you. Vertical line test. This is going to get used all throughout your mathematics. Here's a function that can be graphed easy. Circle. And let's put another one down. Alright, I keep forgetting I want to use my other color. So I've got two different graphs here. Circle and just some lines. What my vertical line test tells me is that if my graph intersects the x-axis at more than one point, then it's not a function. I'm not my x-axis. Do my vertical lines intersect the graph at more than one point? If they intersect the graph at more than 1 point, then it's not a function. So, let's write that rule. If my vertical lines intersect the graph at more than 1 point, it is not a function. Now, what on earth does that mean, Mr. McDougall? Well, I'll tell you. You can go down to Walmart and get or I don't know, sorry Walmart, didn't mean to plug you, not really a fan too much. You can go down to the river, why not, and get your $7,000 vertical line tester. Or my little cheapo Bic pen, which probably cost me like 28 cents. Your vertical line tester is going to come across your graph and see, let's see here, my vertical lines, ding, 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 comes down, making some arbitrary lines here. Try this first one. Does my vertical line intersect the graph at more than 1 point? Here and here? It does. Over and over and over. And what that says is if x was 3, then y could either be, let's just say that's -2 or +2. That goes directly against my definition of a function. Let's do a vertical line test on the other graph, shall we? See, each line only intersects at one point at a time. This tells me that for every one x value, there is only one y value. And I do believe I've taken enough of your time today. So on that note, I hope you've enjoyed this episode of McDougall's Math, and have a good evening, because it is really late.